Hi everybody. This video is going to be about going through the idea of what vectors are a little bit more carefully. This is something that I've been sort of using in previous videos, but I haven't really carefully explained what are vectors exactly and what are their precise properties and how do you work with them, which is going to be something that needs to sink in this early part of the course. It's not the most exciting subject, but all of the stuff we do for months is going to be based around using vectors, working with vectors, dealing with vectors. So you need to have a really good understanding of what vectors actually are. So first of all, the part that I kind of already said in previous videos, that vectors are more than just numbers. They actually have two properties. And I'm talking about two-dimensional vectors here have two properties. If it was a three-dimensional vector, it would have three properties and so on. But we'll just focus on two-dimensional in this class. So vectors have two properties. Number one, you have the magnitude of the vector, which is, well, we'll talk about what they are momentarily. And number two, you have the direction of the vector. So that's the way I explained it previously. The way that we represent a vector visually, as I have been doing in previous videos, we represent it normally with an arrow like that. Okay, so represented with an arrow. The length of the arrow represents the magnitude. And of course, the direction of the arrow represents the direction, not surprisingly. So for instance, for the vector that I drew here, we have here the magnitude of the vector is that actual length there. Now, a lot of times in practice, we're not going to be drawing vectors like with rulers on graph paper or something like that. So a lot of times I'm not so careful with making sure that the lengths are correct. But theoretically, the length of a vector should be proportional to its magnitude. And then you also have the direction that this vector is pointing in. And by that, we mean, like, for instance, if you draw a coordinate system with the vector's tail at the origin, what is this angle here of which way the vector is pointing? Notice, by the way, as a side note here, the magnitude and the direction of the vector matter. The actual location of the vector on the page doesn't matter. It's only the magnitude and the direction matter. So for instance, if I were to grab this vector, I can actually do this in Zoom, which is nice. So if I take this vector and move it to another location on the paper, you'll notice it still has the same magnitude and it still has the same direction, because the length, remember the magnitude is the length of the vector. So the magnitude is the same as it was before. And also, if I draw this coordinate system, the angle here is the same as it was before. So moving a vector around spatially doesn't change its properties because it's only the magnitude and the direction that matter. So the vector is literally like pointing in a certain direction at a certain length. Remember my original analogy in like the first video where I said, for instance, an example of a vector is go 2 miles east. So notice the two properties are in there. 2 miles is the magnitude, east is the direction. And also to what I'm saying right now, notice it's like 2 miles east of here, regardless of where you are. The vector is 2 miles east of wherever you currently are. So like, it doesn't matter where you are, the vector still has the same meaning, so to speak. Okay, so that's how we represent a vector. Next thing I guess would be how we write vectors mathematically. This is another thing I kind of mentioned in previous videos, but let me say it carefully. So let's say we call this vector A, for instance. So this will be vector A. The way that we would write that down is we would put A with an arrow over top of it. You can either draw your arrow like that, or you can draw your arrow like that. There's a few different ways that people do it sometimes. If you're typing, you can put the A in boldface, and that's another way that people denote vectors, because it's a little bit of a pain to get the arrow in there when you're typing. So that's the way that we represent the fact that it's a vector, is we draw the little arrow over top of it. So this here represents the vector. If we want to talk about just the magnitude of the vector, the way we do that is put it in absolute value signs. So normally the most clear way to write the magnitude of a vector would be like that. To put the vector symbol on there to remind us that A is a vector, and then put absolute value signs around it to denote we're just talking about the magnitude of the vector. Sometimes people, this is the clearest way to write the magnitude. That doesn't necessarily mean it's the only way you'll see it. Some people will write the magnitude just as absolute value A, because they figure, once you take the magnitude, it's not really a vector anymore anyway. But this can be a bit confusing because, you know, was A a vector? Was A a number? What are you taking the absolute value of a number? Or are you taking the magnitude of a vector? It's not super clear. And even less clear, a lot of people will just write the magnitude as A without the arrow over top of it. So some people use that idea. A without the arrow is magnitude, and A with the arrow is the whole vector. But that's super confusing because you don't know if someone just forgot to write the arrow or if they actually mean the magnitude. But nevertheless, you see that sometimes. So I would recommend this method. That one's very clear. If you're writing the direction of a vector, the direction is, sometimes it's specified in words, like you might say plus X direction, or you might say west, or whatever the case may be. But in the most general case, we usually specify the direction with an angle. And the standard convention of how most people do it is you measure the angle counterclockwise from the plus X axis. That's the standard convention that people in the math world use. So we also use it in physics. So the vector I drew over there, you'll notice that that is the angle that I wrote in over here. You'll notice that I drew the angle from the positive x-axis. Oops, not the positive axis, positive x-axis, and I went counterclockwise, which is this way. Sometimes this can lead to kind of weird situations. Like for instance, if you have a vector that points down like this, the angle that you'll actually measure is you start from positive x, but you have to go counterclockwise. So you end up going all the way around like that. And that's your angle that you're specifying, which is weird, but you get used to it. You don't have to always specify angles that way, but that's kind of the standard method, which also means that if you're answering like a mastering physics question, or like you know, an automated grading question of some kind, a lot of times it will say measure the angle counterclockwise from the positive x-axis, because that's kind of the standard convention. So it could be anything from 0 to 360 in that case. Okay. So let's see, anything else I want to say about vector basics? This is probably a good stopping point for this video, because the next thing I have to talk about is a whole can of worms unto itself, which probably deserves its own video.